All right. Welcome, everyone, to the Kubernetes SIG Cluster Lifecycle Cluster API Provider Azure Office Hours, March 31st, 2022. We are abiding by the CNCF Code of Conduct, and please use the raise hands feature if you have questions, so we can keep this meeting nice and orderly. I'm sharing the agenda. Now is a great time to add your name to the attendee list if you like, and add topics because we have plenty of time to discuss them. We have one thing on the agenda so far today, which is Jack is going to talk to us about the official cloud provider Azure Helm chart. Is there anything else that we should go over before we jump into looking at that? Oh, wait, I know what we should do. We should welcome any new participants. So is there anyone who is new to this call and would like to say hi? If so, please unmute and say hi. All right. Perhaps we have people who have come before and are very excited to see Jack talk about the Helm chart. Okay, Jack, did you want me to open the PR or sorry, the GitHub, or should I let you share?
I probably should, do all the needful to get screen share permissions. Good morning, everyone.
Yes, absolutely. Let me just stop sharing and get you added.
So while that's happening, I'll give a little bit of background to what we're talking about. So the main thing that folks might not be too familiar with is the concept of out-of-tree cloud provider. So backstory is traditionally in Kubernetes, the sort of big 3 or 4 cloud providers, Google, Amazon, Azure, were included in the Kubernetes codebase itself and compiled into the main bits of controller manager running on your cluster. And so depending on how you invoked your controller manager runtime when you started up your control plane node VM, you would either be running in an Azure context or in an AWS context or a Google context. That was sort of it. So there were cloud provider specific configurations that you could pair with your controller manager running in that context, usually via a file running on the control plane node file system. Anyway, over time, it was determined that to increase flexibility and to sort of execute the correct separation of concerns, it would be better for the cloud provider runtimes to be distinct from the Kubernetes bits, the controller manager runtime. And so a multi-year, like literally probably 6-7 year at this point, effort has been underway to do that across all of the cloud provider vendors in the ecosystem, including Azure. So for the last several years, the cloud provider Azure maintainers have been doing lots of hard work to do that, to allow folks to run the cloud provider as a distinct component. And they cut 1.0 about a year ago or so. So what this means in practice is that you, when you are bootstrapping your cluster, you're going to have a distinct set of pods running on the cluster that are responsible for doing Azure work, and as distinct from running inside the controller manager runtime itself. This introduces, does anybody have any questions about this background so far? Cool. So this introduces some interesting challenges for cluster API workflows because we now have to bolt on separate Kubernetes resource specifications as part of the cluster, because arguably the cloud provider runtime is a sort of foundational intrinsic part of your cluster definition. It's not something that you can do after the fact. So it is sort of comparable to the way Cluster API has dealt with CNI in the past, where it's separate but equal kind of thing. It's like a part of the cluster, but it is not handled by a Cluster API primitive. And so the way that we have sort of referenced how you can do this in the Cloud Provider Azure repo is similar to how we referenced how you can install Calico. So we keep a standard Calico reference as a static Kubernetes resource spec expressed in a cluster resource set. So feel free to ask questions if you don't understand what a cluster resource set is. It's essentially a thin wrapper, cluster API wrapper on top of sort of arbitrary static Kubernetes manifest specification. But this allows you to define a cluster resource set in your cluster template and get all of those static Kubernetes resource specs delivered to your cluster at cluster creation time. So it's really convenient, but the problem is that cluster resource set is an alpha feature that isn't enabled on all cluster API management clusters. So by relying on reference templates that depend on cluster resource sets, we're implicitly requiring any of our user base community who's using those reference templates to enable cluster resource set on their cluster API management clusters. They may not have already done that. And it's not obvious how to do that for folks who are just sort of hopping into the cluster API ecosystem through the Azure front door. So it adds an additional level of friction for building clusters that are actually functional, that actually have CNI. And then in the out of tree cloud provider scenario, are running the out of tree cloud provider Azure bits on their cluster. But to go back to the original point of this digression, the external cloud provider stuff has been in the CAPC repo for a long time, probably a year or so, expressed as cluster resource sets in a reference template. And we test that as an optional test on PRs and on regular daily or every 4-hour test grid jobs to make sure that the out of tree cloud provider bits that we are aware that work continue to work in our sort of standard cluster definition scenario. Any questions?
I have a lot of questions, but let's go to Ashutosh first because he has raised his hand.
Thank you. Thank you, Jack. So you mentioned about this optional tests that are running. So this means that this test would have enabled the cloud provider external flag to make the external cloud provider as Azure work.
That's
Is
right.
my understanding right? Okay,
so,
and then, yeah, go ahead.
Well, it might be easier to just demonstrate it visually. I'm not sure if I'm able to share screen.
You should be able to share. And I think that related, the thing that was popping into my mind was, is this something people toggle on and off on active clusters, or is it something that they only set the one time and then can't change? I thought I heard the word immutable in there somewhere, and so then I was confused.
Right. No, it's not something that you toggle on and off. It is something that you do want to maintain independently of Kubernetes itself. So that's an important distinction, is that the cloud provider, when you're running your cluster using the out of tree cloud provider, you're using bits that are, can you folks see a ugly old GoMod change set?
We can see the change set, though the font is perhaps a tiny bit small.
I bet it is. Cool. So yeah, the cloud provider bits, when you're running in an external context, move forward independently of Kubernetes. So when there are bugs in the Azure part of the surface area, they're almost always patched before a new version of Kubernetes on the appropriate version of Kubernetes is released. So you're able to consume fixes to various bugs in the cloud provider area much more quickly if you're running out of tree or external. So to answer your question, the key aspect for how we test out of tree cloud provider, if this is your question, is this is an open PR that I have that demonstrates what eventually I'm going to get to with Helm. So we are in our reference template here that we use to test out of tree cloud provider. You can see all this negative differential here. We're removing all of the cluster resource sets. So these are all of the Kubernetes layer specifications that we use to install the out of tree cloud provider as distinct components. So this is how we test it right now, is that the template itself during cluster creation time includes a cluster resource set, which is going to put this static pod on the cluster, which is running the Azure Cloud Controller Manager. So this is what you get when you run the out of tree. Instead of having it be a part of the controller manager, you get a distinct Cloud Controller Manager pod running Azure bits only. And then there's another piece called Cloud Node Manager. So in this PR, we're removing this. Go ahead.
Sorry, quick question. Cecile is asking in the chat. Are we looking at the right thing? Are we supposed to be seeing just go mod right now, or should we be seeing something else?
Oh, is it not scrolling down? Or up?
Nothing is scrolling at all. Sorry.
Okay. Oh, it says my screen share is paused. I don't know why it says that.
How exciting.
Oh, resume share. Okay, so sorry.
There you go.
Remember what I was babbling about 45 seconds ago. So this is what I was scrolling through. So sorry about that. So this is the reference template that we use to test. And we are removing all these external cloud provider bits in order to use a standard canonical reference of cloud provider that works on Cluster API, that works on CAPC, independent of this cluster resource set. So that's sort of what I'm going to demonstrate. But again, the reason why this is undesirable is there are two main reasons. One is that we in CAPC, the folks who maintain these reference templates, have to continually move these bits forward or this specification forward. So you can see what we do right now. There's literally a hard-coded version of this Cloud Controller Manager piece in there. So to keep this fresh, we have to independently move this forward, every week or so. Their releases fairly often. And then secondarily, the cluster resource set is not a sort of native built-in. You definitely know that you have it CRD that you get with Cluster API. You have to explicitly opt into using this, which we as CAPC maintainers are familiar with, and we do in our test CI. So when we build kind management clusters, we definitely enable the feature flag that allows us to use cluster resource sets, but it adds additional friction for users who don't really need to know about this kind of thing, and will basically execute a template that won't work on their management cluster.
Cool. So my question, one more question, that I wanted to understand, when we do run this test, like how do we instruct the kubelets or the responsible components to be able to talk into external cloud provider? Like I know for a fact that by default, until we, don't specify, whether you want to use in-tree cloud provider or you want to use external cloud provider, are we like using some flag to tune that?
Yeah, so I'm not fully, I don't have the full expertise to understand exactly how this works, but I'm confident that the cloud node manager component, which is a daemon set running on every single node in the cluster, does some of the node specific, that is how you make the nodes themselves aware that they're running in an external cloud provider context. So they have separate bits running on each node, communicating in an Azure context back to the mothership, so to speak. The way that you instruct the control plane that you're running in a I wonder if it would be easier to just switch to VS Code at this point.
So just to like add more, go ahead, Cecile.
Oh, I was just going to say, I know Cecile had something she wanted to add there. So maybe before we switch away, we should add that.
No, actually, Jack was just going to head the way I was.
Well, there's a simple flag. So the same flag that you've been used historically to say I'm running controller manager in an Azure mode. I'm running controller manager in a Google mode. That flag has been overloaded since the out of tree effort has commenced, and there's a new flag. There's a new value called external. I'm trying to see if I can find
line number 69. I can see.
You found it. There we go. That's exactly right.
16. Yeah.
And so this is then dispatched. This is the kubeadm spec. This is then dispatched under the hood to the controller manager runtime. So it knows to basically, I am not going to do any cloud provider operations. I'm running them in an external mode. And I don't know exactly how the plumbing of the Azure Cloud Controller Manager works. There's probably some simple labels or flags that that are used to know to do that work.
I mean, the only reason I asked this question was like I was trying to actually upgrade 1.22 to 1.23 in management cluster, and then there are some like CSI migration flag like Azure Disk CSI migration that's been enabled by default, and then I just wanted to use external cloud provider, but then the upgrade fails. So I was trying to validate and understand, is there anything like I'm missing, but I'll take a look once more. I responded on the issue. There is one issue, I think, Jack. I don't know who has opened down, but there is one issue about this, and I've like responded to whatever I was trying to do. So yeah, that
Okay.
makes sense.
Cool.
Thanks.
And I'm glad you brought up the CSI driver. So
Yeah.
that's also, I believe, something is this right, Cecile, that we deliver as a cluster resource set. So that's another
Yeah.
candidate for if we're able to reach consensus on this solution of using Helm as a reference delivery mechanism to get these super important cluster bits, but not actually part of the cluster bits during bootstrap time. If we can define a workflow that does that conveniently, then that should greatly, I don't want to say ease because it's not actually easier, but it's better. But when you go to upgrade your cluster, you will upgrade your cluster independently of CSI, independently of CNI, independently of out of tree. The more likely scenario that will empower you is you can upgrade your CSI without upgrading your cluster.
Right, Cecile?
Yeah, we're actually not installing out of tree CSI at all right now, which we need to start doing. And it's actually, I think, in terms of timeline, a little more time sensitive than Cloud Provider, because Cloud Provider was delayed. Like, it's been pushed back many times, but it was pushed back to 126, I believe, the default out of tree Cloud Provider feature. But for CSI driver, it's default starting in 122. And I believe 124 is when things start breaking. You're not able to use persistent storage if you don't have an out of tree CSI driver installed.
All right, Ashutosh?
Just one PSA, like, the CSI migration thing works fine. Like, I just tried to do the like 1.23, the flag is like enabled by default for at least Azure Disk CSI, like manually verified everything for the existing PVCs, and after installing the external CSI driver, just wanted to let you folks know it works good. So
Great. Okay.
Okay, I'm going to start because we're 20 minutes in. We have an hour, right?
We
anybody?
do. We did have one other question while you're preparing your VS Code share. We'll see if folks want to answer. I don't know if you want to, Megana, if you want to unmute and ask your question or not, but you asked about a reference architecture for deploying CAPZ in air gap environments. I don't know if we have an answer for that. Yeah. Do you want to talk a little more about your use case while Jack is getting set up?
So if I were to deploy CAPZ in an internet restricted environment, so I wanted to know if there's a reference architecture that I can look at so that I can have like more details about where the management cluster should be. Should it be in the private subnet or should it be in the public subnet? So
the silence you're hearing is
Cecile might have thoughts
respect
on
for
that.
the complexity of how to answer that question.
Yeah, I'm not. Yeah, I don't have the answer you're looking for, probably. There is no architecture reference or anything like that right now. I'm personally not aware of anyone who has used CAPZ in air gap or internet restricted environments so far, but I know that it will be a use case for many customers. So it's something that I think we want to look at together as a group for sure in the upcoming periods. That being said, I'm not sure I understood exactly what you meant by private subnet or public subnet. Subnets aren't public or private in Azure. There's security rules which allow your like traffic, outbound and inbound traffic in and out of your virtual machines that are in your VNet, and that can be restricted. So you can restrict the outbound traffic such that your VNet can't, or your VMs can't reach to the public internet. And I think the only thing that would limit in a cluster API scenario is what images it can pull and what binaries can be installed, which means that you'd have to have an OS image which has all the required dependencies pre-baked into the image or pre-installed, or something that makes it so that you don't have to download anything when the cluster first comes up. I think one thing we need to start doing is testing that scenario. That would be the first step, like having a test that basically just cuts off internet access outbound and makes sure that the cluster can be created properly.
Awesome.
David.
Thank you. Yeah, David.
Yeah, as far as where your management cluster goes, that really comes down to what your requirements are. The other side of it is you could probably have a registry within that private, available from that private network. So you could put images over there. Normally, in cases before, we would have virtual machine images that you would probably want to load into a shared image gallery into that inside that private network so that you can access those images. There's a handful of stuff that needs to get built out there. And if somebody's passionate about it in the community, we would love to help and figure out how to document this so that it's at least we can say, hey, here are all the pieces that fit together. And you're gonna have to kind of figure out what best fits your use case, but we can at least give some guidance.
Okay. Josh, I think you maybe wanted to weigh in on that. And then I think Jack is ready to show us some stuff.
Yeah,
Yeah, I
I'm
just
feeling
want-
not. Sorry, Josh.
wanted to speak briefly a little bit more to the context. Megan and I are developing a lot of the end-to-end tests for Cap A as well, and have been working on air gap for Cap Z. And so we were looking to see if there was like a validated architecture around air gap. The working design right now is essentially a non-restricted management cluster that is paired with a virtual network with a restricted, subnet, and then kind of going from there. But it sounds like we're kind of free to design this. So I don't think that there's a problem there. We just wanted to make sure that we're following best practices if there was anything written out.
It sounds like you have an opportunity to help define those best practices, which is awesome. So, all right, thank you. Jack, do you want to show us stuff now?
I seem to have come to this meeting with a broken tilt environment.
Oh, okay. If you want to just kind of show us some stuff in the files so we know which things to look at.
I'm wondering, can anybody debug this really quickly?
I can give it a try.
Indicates that the Cap Z controller manager is not running fully, or something is broken. Is it? Does it say it's running on the? If you scroll up and tilt. No, it's red. That's why.
Pair
Oh, looks
programming
like the
time.
image.
Did you run the CI script and then open up your?
Yeah, but I deleted everything. I did do that. Thank you, James, for the empathy. Looks like you've been in this boat before.
Yeah, you can't create a tilt cluster and then run CI script and then go back to the tilt cluster. You have to clean up some files.
Oh, I thought it was just
also-
as simple as cleaning up the kind clusters.
Josh, you still have your hand up. Did you have something more you wanted to add?
No, sorry, I'll fix that.
Oh, okay.
Well, I'll time box this for like 2 or 3 minutes because I think it is effective to demonstrate it actually.
Oh,
But if not, I
absolutely.
can walk through the code.
Hey Jack, did you see the file that gets mutated during the EDE test?
To get
The
status.
Yeah, so git status, and it's going to be one of the config patches.
Oh, I do see it. I just got it. I just nailed it. Okay. All right, that should work. Thank you. I just need to look at my git diff. By the way, have we done a demo on how to run EDE locally? It's really convenient when doing tests. Have you demoed that, James?
We didn't get to doing it last time. We were going to do like a follow-up, I think.
Yeah, I think that'd be super useful for folks. It was very helpful for me. Okay, cool. Thank you for your patience, everyone. So while this is happening, I'll talk through what this is supposed to demonstrate and call out some of the benefits to doing this with Helm. So, and while I do that, let me get a couple of, let's see, do I have a cloud provider? So I'm on the landing page of the GitHub Cloud Provider Azure out of tree project. So one thing that is a challenge, I referred earlier to the flexibility of being able to manage your Cloud Provider Azure bits independently from your Kubernetes bits, but that also prevents challenges. One of the challenges historically is that the out of tree project was managed using a distinct release version semantic compared to Kubernetes. So this project maintains a separate release channel per Kubernetes version, and this is clarified here in this matrix. So, for example, for Kubernetes versions running 1.20, the Cloud Provider bits to run are on the 0.7 release channel. For 1.21, Cloud Provider went 1.0, and so the bits to run are 1.0. For 122, it's 1.1. For 123, it's 123. So that's kind of crazy confusing. And it's actually really good that this leap has happened, because this will predict going forward, it's going to be a little bit less confusing. But even the fact that they are running, that these have been rationalized where we have a sort of corresponding major dot minor between Kubernetes and Cloud Provider, it's still challenging to pick a known working version of the Cloud Provider Azure bits generally, because it's highly dependent on the version of Kubernetes you're running. So Helm allows us to do that. So when you define a Helm chart, you can introspect at runtime the version of Kubernetes that the Helm chart is being installed upon. And based on that introspection, you can choose the right Cloud Provider version to run in your cluster. So it allows for really convenient gestures for users to do a Helm install, refer to the chart, and it's going to automatically pick the right bits for you. So earlier I demonstrated on that diff that we have been maintaining a static version, so 1.1.5. So if we go over here, we can see that correlates to 1.22. So what that means is that we don't really have any way to test Cloud Provider bits across the set of supported Kubernetes versions. We can only test, this template only works on 1.22. And that's not sort of obviously communicated. It would be hard to document in a clear way. So Helm will allow us to eliminate that bit of manual maintenance, and we can simply refer to a Helm chart that will work with all of the versions of Kubernetes that we support. Does that make sense? Cool. All right, let's see how
Definitely. Thank you.
Tilt is doing. This looks better. All right, so I'm going to, for folks who don't understand Tilt, I'll try to talk my way through this a little bit. I'm using this handy dandy Tilt front end to build new clusters using the reference templates that we maintain in the CAPC cluster. So I just click the magical button to create an external cloud provider, a new cluster running that reference template. And I'm going to see if I can follow progress here. Not yet. So this will quickly. And what I'm going to do, the easiest way to demonstrate this is to build a bunch of these on different versions of Kubernetes to see that the Helm chart that we use will choose the right version of Cloud Provider Azure for us. So I'm going to do that by building a cluster, and then so you can see right now that my Tilt config, and again, this Tilt is this thing I'm using right here, is configured with this version of Kubernetes, which means that I think all of our reference templates that aren't, anyway, most of our reference templates are being informed by this configuration to know which version of Kubernetes to build. So when I change this and I build a new cluster, it will build with a new version of Kubernetes. And then the idea is to demonstrate a common Helm gesture that will install different versions of the Cloud Provider bits because it will be able to introspect at runtime what version of Kubernetes is running. All right, so that looks like it's done. So I think I'm just going to go ahead. Let me take a note of which one this is. 42 seconds. All right, so I'm just going to change this right now. So 123.5, I think, is a working version we have. So if I save that, then Tilt is smart enough, it's going to go into automatic updating mode. And once that's done, then I will great. I'm going to ignore those issues.
Can you tell us what Tilt's automatic updating mode is or does for people who aren't familiar with it?
Yeah, sure. So this is it's similar to any kind of convenient IDE that has a file watcher. So basically, it's watching a set of files, and when those files change, it's sort of rescaffolding its thing. So similar to, yeah.
Sure, just like a watch,
it's a
like
file
a
watcher
watch
thing.
feature. Wonderful.
That's right. So when I updated this file and hit save, Tilt observed that the file changed and it rebuilt itself according to this new change configuration. And so the idea is that the second cluster that I built will be built with 123.5. So what's a 121 version? Can someone off the top of their head? 10? Will that work? I can just
10 is the most recent one. We weren't able to publish 11.
So we have 10.
Yeah.
Thank you very much, Matt. So I will wait until that's finished, and then I'm going to save, do the same thing again. I should have 2 clusters now. Terrific. For posterity, from oldest to newest, it's going to be 122, 123, 121. That doesn't make any sense, but we'll try to remember it. And when this goes updating, okay, cool. And so now I will refresh this again. So that's pretty convenient. So that's a nice little demo of how cool Tilt is. So shout out to all the folks who've been maintaining Tilt for the past couple of years on CAPC, and also the maintainers of Tilt themselves. All right, so now I can move along a little bit. So we've got clusters here. So let's see if we have a kube config secret for the first one, and then so looks like not quite yet. So once we get our secret, then I will connect to the cluster and look at all, oh, there it is. All right. So we copy pasta this. Hopefully my scroll back is going to help me. Okay, get secret. Here we go. You can see this is not my first rodeo. So I'm going to grab the secret to this first cluster, and if memory serves, this is running 1.22. something or other. All right, so I'm going to grab this secret, put it in my home cube directory. I'm going to then set my cube config to point to it, and let's see what we got. Hopefully there aren't secrets scrolling in the background here. I guess the Zoom show only show one at a time, so. You can do it, you can do it, you can do it.
We can subtly see a tiny bit of what's scrolling entertainingly.
Interesting.
Since I think you shared several bits of either several windows or your whole desktop, not sure.
Yeah, I've got
You're
4.
not just sharing one window.
I'm going to mute and do some housekeeping for 7 seconds.
Okay. This is exciting because I'm imagining that a lot of people end up needing to do this. And it's cool that there's open source projects like Tilt that are very helpful in this ecosystem. Shout out to tilt.dev.
Also, thanks to Jonathan Tong, who's not here, who made it so you can launch multiple clusters by clicking on that.
Awesome.
Oh, I completely took that for granted.
That was a few months ago. He added that. It's great.
Okay, 122. That's what we want to see. Okay, so unfortunately, we have to wait a few minutes. We've got 23 minutes left. I think we're going to be okay here. All right, so let's remind ourselves what we're doing here. I am running on this branch here, which has removed all of the cluster resource set definitions from, so in Tilt, I was creating this column list. In this column is a convenient representation of all of the cluster definitions it's actually it is in this folder templates. So it strips off the prefix cluster-template, and it strips off the suffix .yaml and presents them as a cluster definition called external cloud provider here. And so I have been building clusters with this spec right here that we're looking at. So it's what we're doing, but compared to main, we've removed all the cluster resource set stuff. So what I should expect to see on this cluster is that there are no cloud provider bits running on it. Maybe someone on the call can help get like the most definitive confirmation of that. But once we have a controller manager pod, I can hop into it and it should publish the way that it was built. It should have that -- external in it, but it's not quite there yet. KubeADM is doing its thing. Actually, this is it. It's just, there's so much semantic information there. Okay, so I'm gonna look at this just at the top, and I have to give it a namespace.
And how could you tell that that was what you were looking for?
Because I've been doing this a lot, but this in particular is the main sort of tell. And then this is semantic suffix information that we append to the pod that gives it like sort of cluster identifying information.
Great, thanks.
Let me see if, but it looks like maybe it's not running in the appropriate verbosity to show that it's running externally. Sorry that this is so, yeah, we're gonna have lots of externals here because literally the name of the cluster.
It's very informative. I think this is great because it gives people an idea of what to look for when they're actually doing it.
I'm not gonna even ask, I'm just going to assert that the font is too small.
Fonts.
Okay, I think we are ready here for some action. Okay, cool. So can anyone give me a hint as to the correct, there is definitely a status transition that has not happened because the cloud provider bits haven't been installed in this cluster. What's the quickest way to like get that on this cluster? That would be on the CAPC
nodes.
CRDs, right?
If you look on the cluster notes, you should see that they have no provider ID.
Great. Let's see if that's true. Or if this
Maybe a describe.
Introspect, yeah. All right, let's see what we got. Provider ID, no result. Is that definitive enough?
I wouldn't expect no result. I would expect an empty. Actually, I'm not sure. Oh no, it should. You're right. It would be no result. It would be.
It says it right there. Uninitialized cloud provider on the.
Oh, there we go.
Thank you, James. Okay, cool. So yeah, so we're running a cluster that, from a certain point of view, it's running, it's up, but it can't really do anything terribly interesting because it doesn't have a cloud provider context at all. So at this phase, again, this is a 122 cluster. So what we're going to do is demonstrate Helm install. Not that. You guys can do that on your own time. Is that it? Yes, except I want the cluster name. So I'm actually going to go over to another tab. Say K get clusters. Unset. Sorry about this. And the oldest cluster is this one. All right. Okay, so if you're not familiar with Helm, I'm gonna just sort of skip through this really quickly, so we can have a follow-up office hours on Helm in particular. But what I'm doing here is I'm referring to what is the now definitive Helm chart and repo for the Cloud Provider Azure bits. So the Cloud Provider Azure project is going to maintain its own repo with this canonical URI, and this is the name of the chart that delivers all the bits. And I am setting the cluster name to this because the Helm chart isn't aware of the cluster name, as you can imagine. So that this is one bit of info we have to pass into the Helm chart. So if I do this, promise I'll fix that, folks. Then we have now just deployed our Helm chart. So let's see what we have. All right, we've got a pending cloud controller manager, and we've got the cloud node manager was super quick. So let's do some introspection. So cloud controller manager, okay, get NQ system minus O YAML. All right, so let's go up to the top here, and we are running 1.1.11. Let's check and see if that's what we want to be doing. And that is correct. That is cool. So again, that was not passed in here. There was nothing said like, make sure to get me the 1.1.11 release. We simply installed the chart. The chart introspected the cluster, saw that it was 122, and then the chart is implemented so that it has a dictionary that will look up the right cloud provider Azure version to deliver with that version of Kubernetes. Does that make sense to everybody?
Yeah, that's really helpful. We do have a question in the chat wondering if we're recommending this to users or only for tests.
Great question.
What
you are seeing the primordial process of this, of something that will eventually be the way to do this for users, I think. At least that's the idea. That's what I'm advocating here. Does anyone have any concerns about this from a user perspective?
Shyam, if you want to unmute and tell us more about your thoughts there.
Yeah, so just to follow up on that, so I understand the benefits of using Helm, but I'm wondering a scenario where a user would have like hundreds of clusters, and I thought like CRS would be a good fit in that case because you can just like tag a CRS and then it's going to install the cloud provider for all the clusters. But in case of using Helm, we'll need to like do it for each and every cluster. Would that be a good UX?
That's a great question. So there are discussions happening. There's a proposal by Fabrizio to do something like this as a kind of native cluster API add-on. And were that to have sort of first-class Helm support, then we could probably lift and shift this as is into that new native set of capabilities to allow like a one-click solution, because you're correct that this does break that for actual user flows. But I would like to point out that with that convenience comes something that's very dangerous, which is that the cluster resource set is a sort of fire and forget Kubernetes resource applier. Like it's not going to be able to maintain that over time. And so every time they upgrade their cluster or edit the version of Kubernetes and in some other way, they'll have to sort of like figure out how to reformulate a brand new cluster resource set with a new version of Cloud Provider Azure, or they'll have to do that every single time. Whereas with Helm, I can, so.
And just to bring up, since Jack mentioned it, this is Cecile added to the chat, and perhaps can unmute and say something for a minute about this cluster API add-ons orchestration proposal.
Yeah, so Jack basically said it. I was basically going to bring up the same proposal, but I think this is more like crawl, and then proposal would get us to run. Like this is more of an intermediary step to get us to a more, because once we get users relying on CRS, there's no way out. It's kind of a dead end, and there's not a good long-term support solution. We've talked about it in Cluster API, and there is an understanding that CRS is going away at some point. It's going to be deprecated. So if we get all these users like relying on it for cloud provider because it's the only way to get external cloud provider, I think we're putting our users in a bad place. But if we get them to a place where they have to do a bit more manual steps for now, but at least there's a solution that's going to be completely like portable to use this like new add-on manager based on Helm, I think it would be a better transition story. What do you think, Cheyenne?
Yeah, so yeah, I'm kind of conflicted on this, mainly because we are now adding one more dependency for the user. But I also like understand the point where if a user is like set on using CRS, it becomes difficult over time. Yeah, there's no like perfect solution for this, but yeah, I think the cluster add-ons proposal is a step in the right direction.
Okay, great. Ashutosh, did you have something you wanted to add there?
I was just quick question. Like I had one more question, but I think Sam already asked it. So she's still like this add-on manager. Maybe I'll have to give it a read, but just to understand on a high level, are we, saying that Helm would be the only way, if at all, we proceed with this approach? Like, somebody can use a different package manager or something like that that manages the life cycle of, cloud provider or CSI stuff and stuff like that. So.
Yeah, absolutely. No, it wouldn't be the only way. It's you should take a look at the proposal, but basically the proposal proposes that instead of having like built-in cluster API add-on management and reinventing what's already out there in package managers, to just allow for integration with external package add-on manager tools. And so Helm is just used as a target for like the design and an example. And I think it's probably the way that we would go for the first prototype, but it could be, also done the same thing with any other add-on manager out there. It just needs to have its own CRD and controller, but each of them would be independent.
Makes sense. Thanks.
Great, thank you. All right, so Jack, you want to bring it home? We have 10 minutes left. What are we going to look at here?
Cool. So the final thing I wanted to show on this cluster is that the Helm chart has delivered us a solution for Windows as well. So once we add a Windows pool or machine to this cluster, we will be running, we'll be cooking with gas. So this is actually, I feel like this should be demoed across the ecosystem in Kubernetes more often. Having a daemon set that's like ready to go once a particular node selection is triggered is the right way to do this. And so I'm really excited that this has Windows support baked in. So basically, when you install your cloud provider Helm chart, it doesn't care about Linux or Windows. It primes the cluster for both. Okay, cool. So the last thing I will do is, let me go away from this, is go through my quick demo now that I'm confident this is probably going to work actually. All right, so from oldest, so this is the one I've looked at. So let's do a little bit of this action. Okay, get secret, and I will place this. So this is our second oldest cluster. So memory tells me that this cluster is running 1.23. And all right, let's confirm that. And sorry for this message. I guess my sticky bits on the cube directory are wrong. Oh no, I don't get the message anymore. I'm confused. Okay, cool. 123.5. So let's Helm install. Okay, so I'm gonna just replace this with this. If anyone doesn't know what I'm doing because I'm moving fast, just blurt out a question.
Okay, I have one question in the chat about, are we able to run with no replicas? Like, is this, Shayam was pointing out that we might have been talking about doing something similar for AAD pod identity.
Is the question, is it like operationally normative to run a daemon set with no replicas? The answer is yes. That might be an opinion, but that's my answer. It's my opinion.
It was just an observation. I remember like we were discussing this for like optionally installing pod identity. Yeah, Just the observation.
Yeah, so the conditions in which a daemon set would run with 0 replicas are if essentially if the node selector configuration yields no nodes on the cluster. The reason I think that's operationally normative is because the presence of certain types of nodes on a cluster is not static. So over time it could change. So having a daemon set there be ready to do its thing when the proper nodes arrive, and then ready to kind of move into standby mode when those nodes are no longer there. That to me is a good operational best practice. Okay, so I've installed Helm on this. I didn't actually verify that it wasn't running the Cloud Provider bits, but let's look here. So now we've got everything is running, and this should be running 123. So I'm going to go up here. Yeah, here we go. 123.8. All right, and then our final cluster. Any questions before I quickly hop back on the merry-go-round? So now I'm talking to my local kind management cluster again. I'll get the most recent cluster now. That's going to be this one. And I'm going to get the secret. Could have just copied that hash, but oh well. And
you can put kubeconfig at the end of 28330.
Oh yeah, thank you. Yay, okay. Export kubeconfig equals that. Okay, so we are expecting a 121 cluster here. Oh yeah, and it's giving me an error. Cool. And again, before I do this, let me just validate that. Actually, let me validate that this node is running uninitialized. That's the right way to do this demo. Up to the top.
And Cecile had a thought to add here.
Please just interrupt. Uninitialized.
Just a question. What's the flow like when you upgrade the Kubernetes version on your cluster?
What's the flow like when you update? You mean in terms of Helm?
Yeah, like you change the Kubernetes version from 121 to 122, let's say. How do you get the right version of Cloud Provider then?
So that would be, it would be totally independent. There is no automatic flow there. And I know that this seems inconvenient, but maybe this is for a different discussion. I think that it's right to not be overly convenient because these are really are separate things. And so I think they want to be maintained separately for best results. Go ahead, James.
Is that addressed in that proposal? If not, maybe we need to bring it up there.
I think the proposal assumes that the add-on becomes absorbed into the cluster spec, and so, but maybe the upgrade stories aren't specifically. I need to get my cluster.
I think the proposal that addresses that is not that particular proposal actually, but the other one that was brought up at the office hours yesterday with having like runtime hooks and having like pre-post upgrade hooks so that you can say like post my upgrade to this particular operation, like upgrade my add-on, things like that is my guess.
Okay, so we've got this, and this should be running. I'm gonna actually, maybe I'll go over like 1 minute. I'm gonna look for the initialization. That's one thing I didn't do in the demo. So K get pod, just make sure this is using the, what is the root version? 1.0 something or other. Yeah, 1.0.15. Okay, cool. So that's how we expect it. So now let's look for how long do we expect it'll take to get initialized? Whoops. Will it take like longer than 90 seconds that this meeting provides for us?
I'm not going to cut you off in a minute and a half.
Thank you, Bridget. Oh, it already initialized.
Yay.
Demo gods were kind. Okay, so in the final 30 seconds, I'll just mention that this demo was intentionally extremely manual and tedious in order to sort of maximize the amount of information communicated, hopefully. But there is a PR in the CAPZ queue right now, the one I was demonstrating, that does this automatically. So it essentially uses the Helm SDK to do this in the flow of the end-to-end. So it was a little tedious to get this working, but once we get it working, it will just work, of course, because that's how computers are. But in this optional test, there's a tiny little marker that shows the difference that only I probably understand. But we are outputting we're outputting the results of the Helm install in here, and so this is the sort of signature that during cluster create we inject a Helm install to bootstrap the external cloud provider stuff before it then runs the remaining tests. So it really is again at the cost of some complexity, because we're now using the Helm ecosystem instead of cluster resource sets, allows us to, oh wow, look at, we're live streaming James's comments. Cool.
Love it.
We're at time. I'm happy to answer any questions, or I'll be online for the day, so you can hit me up in chat on Slack, I should say.
Fantastic. Thank you so much, Jack. This was very informative, and I imagine people will find you on Kubernetes Slack on the Cluster API Azure channel if they have additional questions. And then we will see folks in 2 weeks, I believe, April 14th. We'll be doing the office hours again. So you can go in the doc and sign up if you want to do demos yourself or discuss something. Add your questions. Thank you so much. Thank you, Jack.
Thank
Well,
you.
thanks for hosting, Bridget.
All right.
Thanks,
Take care.
everyone.
Bye.